Hello and welcome to the demonstration of the IBM SPSS Modeler. Today I'll be conducting a marketing example inside a financial institution, or a bank in this case, and I will show you examples such as data exploration, association modeling, which is cross-sell, upsell of banks' products and services, segmentation and classification, so understanding the attributes of their customers, and then finally predicting, in this case, who is likely to purchase a car loan. Now in front of you is the IBM SPSS Modeler. This is a data mining workbench that allows us to extract data, restructure and formulate data, build models, and then finally deploy them. On the right-hand side, you have three different tabs. You have tabs for different streams, and we're going to talk about what a stream is in a second. We're going to talk about outputs and then models. Right below it, we have tabs for CRISP-DM and classes. Now, CRISP-DM is a consortium of different companies, including the IBM SPSS, of a standard of conducting data mining projects. If you want more information about CRISP-DM, please look at the IBM SPSS website or at crispdm.org. Now at the bottom here, we have different tabs. We have tabs for sources, record ops, field ops, graphs, modeling, output, export, SPSS statistics, and SPSS text analytics. Now within the source tabs, if you notice that they're all round here, and each shape represents each of the different tabs here. So the sources tabs are round, and within the sources tab, we can extract information from different disparate types of data sets, such as databases, flat files, fixed files, SPSS statistics files. We also have included now the IBM Cognos BI cubes, so if you want to bring in Cognos cubes, you'll be able to do that within this package now. We can read in SAS files, Excel files, and so on. And then from this, we have different record apps and field ops, and what these allow us to do is to restructure data so it can be used to help us build models. 80% of the work that's done within modeling is usually getting data into a format that it could be modeled. In this case here, we have a lot of robust nodes within this package that allow you to accomplish this. We have a tab for graphs. And the nice thing about our graphs, they're interactive. So the interactive allows you to look at information and be able to select on information and create selection criteria. We could also derive new variables from those graphs as well. We have a modeling tab here. So this shows you all the different modeling capabilities within Modeler. One thing I like to point out about it is that we have a new capabilities of including what we call classifiers. The classifiers allow us to run multiple algorithms at the same time. During today's presentation, I'm going to show you how one of the classifiers works. We have an output tab, so if I want to write out a file to a table or write out a crosstab or a matrix, I have that capability. And then we have the export tab, which allows you to write out your scores and from your models to your databases or to a flat file if you choose. If you currently have SPSS statistics, you have the capability of incorporating your current products within the IBM Modeler package. And then finally, we have a tab for IBM SPSS text analytics. If you're interested in text analytics, we have another presentation that is on our website that goes through the text analytics part of Modeler Premium. So let's go through the data of this banking customer. And from this, we're going to create what's called a stream. A stream is a process. It's a process of extracting data from disparate data sources, being able to restructure the data, then finally model it, and then deploy it. In this case here, we're looking at customer demographic and we're looking at product data. Now these are two flat files. These could be database files like we showed, I talked about earlier. These could be statistics files, they could be Excel files, whatever. But we want to be able to bring in information from different areas within the organization. In this case here, we're just using two small flat files as an example. So in this case here, I have customer demographic data, so I'm interested in that. And how I got this was literally drag and drop a node to the workbench. And all I need to do is then connect that right to the actual merge node. So in this case here, I already have two of them that are already been edited and define the location where the files are. So I'm just going to drag and connect these to the merge nodes. Once I connect these two, I can go into the merge node if I like, and I could change how they're actually joined. In this case here, I'm just using customer ID. We have the capability of joining them on just one variable or multiple variables. So the option is up to you. In this case here, I merged the information together. So let's go ahead and take a look at what that data might look like. So I'm going to connect a table to that merge node. Right click, go down to run. And then now I was able to combine two different data files together. I have their customer ID, what products they have purchased, and there's customer, there's home equity, there's credit card, debit card, 529 plans. And then on the right-hand side here, these are from the other data set, which is the demographic information, which has the age, income, if they're a homeowner, yes or no, and so on. So I was able to combine two data sets together. And it's not just limited to two. If you have multiples, you have that capability as well. So the first thing I would like to do after combining the data is I want to take a look at the data and get some descriptive information about it. What I did was drag and drop a data audit node. That's all I did here. And then if I run that data audit node, it gives me their customer ID, the home equity, and if you notice here, they're flag variables. That's why you have two unique values. And then at the bottom here, we have some information from the demographic information. In this case here, we have income and age, and it gives me the min, max, and it gives me how many valid. If I double click on income, the graph itself, I could actually step into the information and generate the histogram for me, and I could take a better look at the information. In this case here, we notice that income, majority of household incomes are just above the $100,000 mark. From that, I can create line graphs. I can create another histogram if I like. But in this case here, I wanted to show you a web graph. A web graph allows us to look at data in a way that is like link analysis. So if I want to see how many links between people buying two different products are, I could see all that information in one graph. Now, if you did this in crosstabs, you would have to make multiple crosstabs over and over again and see how many links there are between the products. This way, it allows me to show everything all in one page. Let me show you what I'm talking about here. If I double click on the web graph, I have fields I'm allowed to input. So I have home equity, credit card, debit card, 529 plan, line of credit, and so on. What it allows me to do is bring in those flag variables, and what I'm interested in is showing only the true flags, because I'm not really interested in the people who didn't purchase those products. I'm only interested in people who did purchase them and see the links between the products that they actually purchased. So let's go ahead and run that. Once I run that information, it creates a web plot for me. This web plot has lines between the different products. And if you notice here, there's thin and thicker lines. The thicker lines means there's more links between them. There's a scroll bar at the bottom here, and if I scroll over to the right, I can reduce some of those weaker links and just see the ones that are thicker. In this case here, if you notice that home equity loan and rollover, there's a thicker line between them. If I want to see the numbers, I can point to them, but if I want to get a chart of that a table of that information, all I have to do is click on the arrows and it gives me all that information right in a nice table for me to go ahead and view, and then it shows me the links between them. So once I look at my data and I have a good understanding of the information I want to bring in, now it's time to do some modeling. Now, what we're going to do here is that we're going to build a cross-sell and upsell model. So we're going to take information, we're going to take the same customer demographic information and the product information before, we're going to merge that information, and then the next thing we need to do is tell it what fields we are going to use, and that's what the type node is for. And then we're going to apply what is called an a priori algorithm. This algorithm is used for cross-selling and upselling. Once we run that information, it builds a model for us. This model right here is built from the association model of a priori, the algorithm. I double-click on the model once it's created, and it gives me 4 columns. I have the consequence, the antecedent, support, and confidence. In this case here, in the antecedent, I have the CD and the 529 plan within the first one. So what this is telling me is that people who purchase the CD and the 529 plan are likely to purchase the car loan. It gives me the support percentage, so 16.667% of the cases support this, and there's 87.425% confidence with this being true. Once I do that, I could attach the model, which is already attached here, and I would like to take a look at the scores that were produced from this after we score our table. So from here, I could take a look and seeing what suggestion came up first. In this case here, this customer number 23, the suggestion would be to offer the customer a CD, and there's 84.4% probability of this being true. Now, with that said, if I was in a call center and I'm deciding what products to offer a customer, the first product I would offer the customer is a CD, and there's an 84.4% true probability of that happening. So once I do that, I could write them out to a database. I could write them out, let's say, to an Excel file. I have that capability as well. And from that, I can give a list to somebody saying, these are the products we would like to offer each of those people based on the models that were created. So there's an example, a very simple example of a cross-sell model that you can build with the modeler. So let's take a look at segmenting our customers. Now in this bank example here, a lot of companies do segmentation, and the modeler product, the IBM SPSS modeler product, helps this process dramatically by reducing the time to be able to create segmented models and be able to build clusters. In this case here, I'm going to show how fast it is to actually build a model using a k-means cluster. Now there's other clustering algorithms with here as well. So there's also you have different ones such as k-mean, or with k-means we're just doing Cahonin, two-step, and anomaly. So I'm going to pull in the same products. I'm going to run a unsupervised algorithm, which is the k-means clustering algorithm. Once I do that, it creates a model for me. And once I create that model, I could double click on that model, and it gives me information about the model. So I could look at the different clusters. I can highlight two clusters together, and it allows me to compare and contrast the two clusters. So in this case here, I'm looking at cluster 1, I'm looking at cluster 3. I could look at gender, car loan, homeowner, home equity, rollover, and it gives me some insight of what the attributes are for each of these different customers. Once I do that, I can overlay information. So if I overlay the clusters here, let's say to the 529 plan, I can see what cluster has most of the 529 plan people in it. In this case here, it's actually cluster 3. It gives me the percentages and gives me the frequency count of that cluster. Now, in addition to that, I could take a look at other information. In this case here, I could look at the average income and also look at the average age by cluster. Once I do that, it gives me all the different clusters. It gives me the age on the y-axis and the income mean on the x-axis. And so I could take a look and point to each of the different clusters, and it gives me that information. In this case here, I'm looking at cluster 1. The income median is 118,000, and the average age is 36 years of age. So from that, I was able to create a quick model and be able to take a look at the attributes of this banking customer. Now let's move on to a predictive model. In this case here, the bank is interested in predicting who is likely to purchase a car loan. So in this case here, we have the same data. Then once we do that, we want to start building models. Let's show you how the models are built. We have a type node here. If I double click on the type node, it gives me the fields. And in this case here, I'm interested in car loan. So that's going to be my target variable. This is what I'm trying to predict. I'm trying to predict who's likely to purchase a car loan. Once we do that, we can apply a classifier. This auto classifier allows me to run multiple models at the same time. So in this case here, I double clicked on the classifier and I went under the Expert tab, and it gives me a list of all the different models I would like to run at this given time. I can run decision trees, I have some Bayesian network in there, I have some decision trees, I have neural nets, and so on. If I right click on the node and run it, what happens is it actually creates a model for me. It actually puts it on the right hand side. Here's the model, and then if I want to double click on the model itself, it gives me information about the models that were used based on this data. In this case here, we have Bayesian networks, C5, shade, and so on. If I want to drill deep into each of these models, I have that capability and be able to take a look at what makes up the rules for each of these different models. I could also view it. In this case here, this is a decision tree, so I could view look at the tree. And in addition to that as well, we can ensemble this information. So I have Bayesian networks, I have a C5 model, and I have a shade model here. And by assembling the data, I have different ways of assembling the different models. Now with that, okay, this allows me to use multiple models at the same time. In this case here, I could assemble them based on voting, confidence weighted voting, raw propensity and weighted voting, highest confidence wins, and the average raw propensity. In this case here, we're going to use whatever model has the highest confidence weighted is the one that's going to be used. By doing so, it creates one column for me instead of, in this case here, there was 3 models there. It ensembled them together and chose the best model based on the confidence weighted. Or if you want to run models individually, you have that capability. So if I want to run a C5 model, let's say, and I also want to run a shade analysis, I have that capability and it will create a model for each of them. Now in this case here, we looked at 2 different ones. I looked at a shade analysis, I looked at a C5 model. I connected them. I can compare and contrast them using an evaluation node. In this case here, we're looking at the gains between the 2 models. So you could compare and contrast, and if you notice here, the C5 model works better. And then I could score the data. In this case here, we have 2 different models. So we have the C5 model and we also have the shade model. Once we create those models, like I said, we can export this information into different types of formats. So if I want to export the scores to a database, I have that capability. I could export them to flat files. I could send them off to Cognos. We could write them out to SAS files. So if you have an SD2 file format, you have that capability. I could even write them out to an Excel. Okay, so you have a lot of options to you. Once you export that information, those systems could pick up that information, and you could use the scores, for reporting or to be able to use them within your enterprise. So that concludes our demonstration of IBM SPSS Modeler. If you have any questions, just please contact your account executive to schedule a meeting. And I really thank you for your time. Have a good day.